This lecture deals with a fundamental concept of chemistry. The concept is the mole, and the mole is a count of things. It is analogous to a dozen, which is 12 things, or a pair, which is 2 things, or a gross, which is 144 things. And if you think of it as analogous, I would posit that if you can solve the following problem, that you can easily do mole calculations. So if you're given 2.5 dozen roses, how many individual roses are given? And you know almost intuitively by now that dozens times 12 roses per dozen gives you the number of roses. You plug your values in and you come up with 30 roses. If you can do that, you can work with the mole. 1 mole of anything is equal to 6.022 times 10 to the 23rd of that thing. This is a gigantic number. Just to put it into some perspective, the universe, which is really old, is 13.7 billion years. You convert that to seconds and you get 4.32 times 10 to the 17th seconds. That is still a very small percentage of a mole of seconds. That number, 6.022 times 10 to the 23rd, is also known as Avogadro's number. There is no direct way to measure a mole. There is no such thing as a molometer. And in chemistry, we count out the number of particles in a mole by weight. So there are some mathematical relationships you need to know. Moles times molecular weight equals grams. 3 variables. If you know any 2, you know the third. So there are actually 2 rearrangements that you should remember. Moles equals grams divided by molecular weight, or molecular weight equals grams divided by mole. The second relationship is mole times 6.022 times 10 to the 23rd things per mole equals the number of things. There are only 2 variables here, mole and number of things, so if you know one, you know the other. So there's just one rearrangement, and that's mole equals the number of things divided by Avogadro's number. There are 4 important points. You need to memorize the 2 basic equations, and you need to be able to manipulate those 2 basic equations. Never, ever, ever, ... ever, so you can put as many evers in as you want, put grams and 6.022 times 10 to the 23rd into the same equation. That's the 11th commandment. And please do not forget point number 3. So I think the best thing to do is to jump right in and start doing examples. I believe we have 4 of them. Here is the first. You've got 27.75 grams of calcium chloride. That's equal to how many moles? Stop, figure it out, come back, check your answer. We'll go through it. Go. And the correct answer is 0.2500 moles. The guess system, given, unknown, equation, substitute, solve the sucker, is a great way to tackle these problems. So you're given 27.75 grams of calcium chloride. Because you have the molecular formula, you can figure out the molecular weight, which is a constant, so you actually have 2 givens. We're looking for moles. The equation that relates those things is moles times molecular weight equals grams. We're going to substitute in where appropriate. We're going to solve this by rearranging, and you get moles equals grams divided by molecular weight, which here, with the numbers that we're given, is 0.2500 mole. Problem number 2. What is the mass of 0.375 moles of magnesium hydroxide? Stop, figure it out, come back, check your answer, and we'll walk through it. And the correct answer is 21.8 grams. Here we're given the number of moles, and we can figure out the molecular weight, so that's really a given. We're looking for the number of grams. The equation is the same, moles times molecular weight equals grams. We substitute in the values that we have, and now we can solve it, and there's no rearrangement needed, and you get 21.8 grams. So let's go to example number 3. A medium coffee, on average, contains 3.75 times 10 to the 20th molecules of caffeine. So how many moles are present in the average medium coffee? Stop, figure it out, come back, check, make sure your process is okay. And the correct answer is 6.23 times 10 to the minus 4th moles. Here we're given the number of molecules, 3.75 times 10 to the 20th. We're looking for moles. Well, in this case, we want the second equation. Moles times Avogadro's number equals the number of molecules. Plug your value in. Now you need to rearrange it. Divide both sides by Avogadro's number, and you get moles equals 6.23 times 10 to the minus 4th moles. And so we have our last example. A sample of ethanoic acid, there's the chemical formula, weighs 10.5 grams. How many molecules do you have? And I'm going to give you a hint. Remember the 11th commandment. The usual drill. Stop, figure it out, come back, check your answer. We'll go through it. Go. And the correct answer is 1.05 times 10 to the 23rd molecules. We're given the mass. We can calculate the molecular weight. The unknown that we are asked for is the number of molecules. There is no equation that allows you to go directly from grams to number of molecules. This is the 11th commandment. Do not put 6.02 times 10 to the 23rd and grams into the same equation. So we're going to need multiple steps. We only have two equations. Moles times molecular weight equals grams. Moles times Avogadro's number equals the number of molecules. Based on the information we have, I can calculate the number of moles. Now I notice that once I know the number of moles from that equation, I can plug it into the second equation. That is common to both equations. So I change my unknown here to moles because that I can figure out. So now I'm going to use this equation. I plug in my values, I rearrange, and I have 0.175 moles of ethanoic acid. So I plug that in into my givens. I'm still looking for the number of molecules. Now I know moles. I have an equation that I can use. Moles times Avogadro's number equals the number of molecules. Plug my 0.175 moles into the appropriate spot. I can solve the sucker, and I get the 1.05 times 10 to the 23rd molecules. If you could do those four problems, you can do any mole problem. So that completes our examples. So a quick review. Mole is a word that stands for a number. It's analogous to a dozen. A dozen equals 12. A mole equals 6.022 times 10 to the 23rd things. That is called Avogadro's number. If you can work with dozens, you can work with moles. And we count out the number of things in a mole by weighing them out. So there are two equations you need to memorize. Moles times molecular weight equals grams. Moles times 6.022 times 10 to the 23rd things per mole equals the number of things. And you need to be able to rearrange them as needed. Never, ever, ever put grams and Avogadro's number into the same equation. That is the 11th commandment. To go from grams to number of things requires 2 steps. To go from number of things to grams requires 2 steps. And this completes actually the introduction to moles. Now there are 2 other equations that relate things to moles. We will be tackling one of them in the next video, and the fourth we'll put off for a while. Now go practice your mole conversions.